Hi guys, my name is Dan Perez. I'm out of Myrtle Beach, South Carolina, and my video today is going to present my first trial run of my homebrew controller with a large AC induction motor, 3-phase motor. So let's talk about my motor a little bit. This is a motor that was pulled out of a Mitsubishi forklift. The mechanics at my job were kind enough to let me have it. According to the mechanics and the Mitsubishi representative, this is not a field repairable motor. Now, I don't know how true that is. I mean, maybe the guys at Mitsubishi just don't want to fix this stuff in the field. But I did take this end belt off. I did take the end belt off. Look at how that bearing is situated on the armature, and yeah, it would be very problematic to pull that out in the field. I mean, you kind of need cone heaters and stuff like that to swell the bearing up to even get it on the armature. So, I mean, you need some advanced tools to replace it. The encoder in that bearing is not completely bad. It uses 2 phases for in a quadrature configuration to detect speed and direction. One of the phases still works, so it'll work just fine for me. I only need 1 phase. I'm not worried about this motor spinning in reverse. I'm only worried about speed, and my controller will support the controller in that fashion. I mean, my controller will support the encoder in that fashion. So this is a smaller of the 2 motors I got. I have another motor that had the same kind of encoder problem, and this one's over here. Let's see if I can run up here real quick in my shop. So I know it's kind of hard to tell scale-wise how big this puppy is, but I kid you not when I say I cannot lift this motor. I kid you not when I say 2 people cannot lift this motor. I'd be surprised if 3 people could carry this motor. It is that heavy and it is that big, but it is a beautiful motor. I mean, I love this motor. I mean, that's a big boy right there. It suffers from the same problem that the other motor had. It has a bad encoder. I've put my scope on it, and I verified that at least one of the phases of that encoder works, and it puts out a very beautiful square waveform when I spin that armature around. So, other than that, I think the motor is good. A million thanks to the guys at my job for giving me the motor. I mean, I owe them guys a lot. They're really cool. Let's take a look at the controller. All right. So here's my controller, sitting on a chill plate, liquid cooled chill plate that I machined. You can see the water inlet fittings down at the bottom. These are 3 driver boards that drive 3 large 400 amp IGBTs. You can see this controller is nowhere near finished. I mean, I got bus bars and wires and everything hanging off the edge of it, but I just got it set up for testing right now. Got some chunky bus bars on there and 3 snubber caps, 1 above each IGBT. Above that, I've mounted a capacitor tray that just captures my large main caps. Up here is my main board. That's not the final resting spot for the main board. I'm just laying it up there for now until I figure out where I'm going to put it. I'm probably going to mount it underneath the tray upside down when I get a chance. Next to that, I have a little USB extension cord, and plugged into that is a USB to serial bridge, and that allows communication with the main board. Down here I have some current sensing components. These components, when put together, are supposed to form a current sensing board. Unfortunately, I had some problems with the actual board. I mean, the electronics on the board are fine. So I'm waiting for a replacement board. Johannes Hubner was kind enough to send me a revision 2 board to replace it, so a million thanks to him for that. I still got the board working though. You know, I got it kind of Frankenstein rigged with wires jumped across, and it works. Down here I have a pot mounted to this piece of cardboard, and I typically do this, like when I'm doing projects, I'll mount my switches and pots to something like a piece of cardboard or something, just to keep stuff from flopping around. I have this board tied down with a little tie wrap and these guys here. Safety first, you know, you don't want these things banging up against a metal heat sink or something like that and shorting out something, possibly damaging, you know, expensive components, main board, etc. Over here I have which is basically an industrial truck battery. This battery was actually destined for the recycle center. I just sort of borrowed it from my job. I didn't need anything that held a substantial charge. I just needed something with enough oomph behind it just to get the motor spinning. I mean, it still holds a fairly good charge. I was told that this was one of 2 batteries that get mounted in the truck in pairs. So typically one of the 2 batteries would go bad, and then the other one would get lazy as a result. So this is one of the better of the 2. I mean, when I'm done with it, I'll return it back to the job and they can recycle it. I imagine they get some money for the lead in it. I have an amp clamp on here, just looking at my output current. Got a little cheap meter up there, just looking at voltage. Down around the side over here, I got this is a tiny bench power supply. You know, you typically would use this with like a CB radio or something. The only thing this power supply is doing is powering a nice clean 12 volts to the main board. Let's see what else. I don't have encoders connected right now. That'll be my project for this weekend, getting one of these connected to the main board. Okay guys, I don't want you to laugh at the wiring I'm using, okay? I understand that this is not the proper wire for this type of application. However, realize I'm just testing, I'm playing around, I'm having a good time on a Friday night just playing around with this stuff. I don't want to cut up really expensive thick cable not knowing what my final length is going to be. I'd rather just use this stuff. I found this in a dumpster. It's free and it'll get by. Yeah, it might get a little warm, but who cares? It's just to see if this stuff works. Same thing with my my DC bus cables. These things are hardly what you would need to run a motor of this size, but I just wanted to put some type of simple safety in here for now, just in case there was something wrong. Trust me when I tell you I've probably blown through about 10 of the little 10 amp fuses that go in here. I wanted to get some 30 amp fuses, but of course it was kind of late already and I didn't have time to get any. So what I did in the meantime was I just took a very thin piece of wire, wrapped it around the legs of the fuses, and I am almost, well, no, I am certain that that copper will melt in the presence of 15 amps or greater. I've done it. I know it's going to pop. So until I can get me some better fuses, that'll have to be my temporary fix for tonight. I know it's not safe, but hey, I gotta get some progress done with this, and I'm not driving a million miles to Walmart to pick up a 30 amp fuse. Just ain't happening. Anyway, let's go over to my computer, and basically I'm running some open source terminal software. In this instance, I'm running Putty. You can get that for free on the internet. It's a great program. I already got the USB cable connected, so what I'll do now is I'll just verify that I have communications with the main board of the controller. See if I can get focused in over here. So I'll just query the controller. I'll do something like get. See if I can get this thing to focus. Get version. Let's see if I get a response. And yes, I do get a response. I'm running version 2.62. So now that I've established that I have a connection with the controller, I can, start the PWM engine. There's some parameters in here that I've already been playing with. So to get this thing started now, I just have to enter a command like start 1. Alright, and I get the response that the inverter has started. This pot will start generating PWMs once it hits around 30% of its full travel. So basically what I'll do is I'll come down here with my hand, I'll put it on my control pot, and I'll try to gently raise the pot. If I spike this thing up anywhere above 15 amps, I'm going to pop that little pseudo fuse I have in there. So I'll be really gentle, and we'll see if we can get it to spin up slowly. Any second now. There it goes. I'm starting to hear that high pitch whine. And if you look at the end of the motor there, you can see it spinning. Now, I got this motor sitting on this big board. I tried to put it on a piece of rubber, but this board resonates. So I'm pretty sure that what you're going to hear in this video is a lot louder than what I'm actually hearing. She's just spinning around. I don't have the encoder connected, so I don't know what the RPMs are right now. I'll find that out tomorrow. Come on, you gotta wake up, Mr. Meter. Okay, so I'm pulling just under 4 amps right now. 12 and a quarter volt. Let's see if I ramp it up just a little more. And you can see that the current spikes anytime I demand more. I just hit 12 amps there, but you can see that puppy is spinning, and I'm pretty sure I can make it scream if I had some robust wires on this whole setup. So I'm very happy. I got it to spin. Nothing is blown up. I haven't let the magic smoke out of the IGBTs. I do appreciate you watching, but even more so, I appreciate comments, suggestions. This whole thing of 3-phase motors and high power controllers is new to me. It's all experimental. It's a good fun summer project for me. I'm trying to learn, and I'm pretty sure that you guys out there have way more knowledge about this stuff than I do. I would love to be the sponge that could suck up some of that knowledge. So if you guys have any comments, if you see anything that's potentially wrong here, besides the fact that I'm using this thin wire, please let me know. As I make more progress with the project, I'll put up some additional videos. Alright, great, thanks for watching, bye.